Today we are going to discuss a line tangent to a circle. So there are three properties of a line tangent to a circle. So let's have first the first property. First property states that if a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. Supposedly we are going to have this circle B. There is a line there which is a tangent to circle B, and it has a point of tangency which is point A. So this radius AB is perpendicular to the tangent line, which is line L. Again, when we say perpendicular, it measures 90-degree angle. So that's the first property of a line tangent to a circle. Second property, which is if two segments from the same exterior point are tangent to a circle, then the two segments are congruent. So we have here segment PY and segment PU intersect at the same exterior point at point P. So we can say that the measure of PY is equal to or congruent to the measure of PU. If PY is 10 centimeter, PU is also 10 centimeter. That's the second property. Third and final property of a line tangent to a circle. We have here, if each side of a polygon is tangent to a circle, then a polygon is circumscribed about the circle. Now let's see the illustration here. So when we say circumscribed about, so here in the second figure, a circle is inside a polygon. That is called circumscribed polygon. Why it is called circumscribed polygon? Because all the sides of the polygon are tangent to the circle. Okay, while in the left side, or the first illustration here, it is called inscribed polygon. Why it is inscribed polygon? Because as you can see, the polygon is inside the circle. When we say inscribed polygon, what makes it inscribed polygon? Because all the vertices of the polygon are on the circle, right? That's the difference between inscribed polygon and circumscribed polygon. These examples here. Example number 1. Determine whether each statement is true or false. Assume that point P is the center and Q is the point of tangency on the circle. So we have here the illustration. So the measure of angle TQP is equal to 90 degrees. Yes, this is according to the first property, which is RT is a tangent line and QP is a radius of the circle. The radius and the tangent line are perpendicular to each other. Now let's have that is true. So let's have letter B. TQ, line segment TQ is equal to TD. Yes, this is true because according to the second property, that's two segments from the exterior point drawn tangentially to the circle. They are congruent. Okay, that's true. And how about letter C? TQ and PB. PQ and PB. Are they equal? Yes, it's true. What's the reason? The two are radii of the circle. Okay. And letter D. Angle TQP and angle QPQR are equal. Why? This according to the first property is true because tangent RT is perpendicular to the radius QP. When you say perpendicular, the two sides are and the two angles are equal to 90 degrees. So let's have letter E. So line segment RA is congruent to line segment RT. This is false. Why this is false? Because RA and RT is tangent segment to circle, but RA is not, because when we are going to extend it to C, then it is not a tangent segment, and there's no property that holds that the two are equal. So we have here example number 2. If line XY is tangent to circle O at X, if OY is equal to 25 and OX is 16, find XY. So we have here the illustration. So OY is equal to 25, OX is 16, and we're going to find YX or A. Let's denote YX equals A. So in this figure, this forms a right triangle. Why a right triangle? Because in property number 1, YX is a tangent line to circle O, and a radius OX, they are perpendicular and it forms a 90-degree angle. So the figure is a right triangle. So we have here in a right triangle, we have OY is the hypotenuse, which is the C, and YX is your A and OX is your B. So in solving A, so this is the formula. So we will just substitute the given. C is 25, B is 16. So 25 squared minus 16 squared. And 25 squared is 625 minus 16 squared is 256. So 625 minus 256, that is square root of 369. What is the square root of 369? That is equal to 3 square root of 41 or 19.21 units. How about example number 3? Line segment JT and line segment JV are tangent to circle O. If TO equals 5 and OJ equals 13, find JT and JV. So we have here TO, which is 5, OJ, which is 13, and we don't have TJ or JP, because we're going to find JT or TJ and JV, right? So in here, this illustration form another a triangle here, which is a right triangle. Again, why it's a right triangle? Because according to property number 1, if a segment is tangent to a circle, then the radius is perpendicular to that segment. So we have A, which is unknown, so we will be using still the formula of Pythagorean theorem where A is unknown. So we have here square root of C squared minus B squared. So substitute the given formula. So A is equal to C squared, which is 13 squared, minus B, which is 5 squared. So 13 squared is 169 minus 25. That is 144. What is square root of 144? That is 12. So TJ or JT is 12. So what is then the measure of JV? Yes, it is still 12 because according to the second property, if two tangent segments are drawn from the same external point of the circle, the two segments are congruent. So JT is 12, therefore JV is 12 units. Last example, number 4. Triangle ABC is circumscribed about circle O. Find the perimeter of triangle ABC if AY equals 6 centimeter, BZ is 2 centimeter, and CZ is 5 centimeter. Now let's illustrate this problem. So we have here 6 cm is EY, BZ is 2 cm, CZ is 5 cm. Now, AY here and AX are two tangents from the same external point A, right? So what can you say about the measurement? They're equal, so AX is also 6, right? Now, XC and ZC are also two tangents to the circle that comes from the same external point, right? So CZ is also equal to CX, which is also 5 centimeter. Likewise here, BZ and BY. So BY is also 2 centimeter. Now the question is, find the perimeter of the triangle ABC. When we say perimeter, we're going to add all the sides of the triangle. So in getting the perimeter, we will add AC, the whole AC, and AB and BC. So what is AC? Let's substitute. AC is 6 plus 5, that is 11 centimeter, right? Plus AB is 6 plus 2, that is 8 centimeter. And BC is 2 plus 5, that is 7 centimeter. So what is 11 plus 8 plus 7 centimeter? That is equal to 26 centimeter. Therefore, the perimeter of triangle ABC is 26 centimeter. This is according to the first theorem and the second theorem. So in this lesson, we were able to learn these values. The expression of gratitude is a virtue that we should practice in our daily life. The words "thank you" should always be said whenever somebody does a favor. Thank you and good day.